Hey, amazing students. So I hope domain and range is you're grasping the concept. We're going to do another day of domain and range because it's just that important for your understanding because you'll see this all throughout the year. So if you were in class, this will be a warm-up. What is the range of the function? Automatically, I'm like, okay, range are my y values. So I'm looking for how does the graph cover vertically from bottom to top. So I'm looking for my lowest part of the graph to the highest part of the graph. So automatically, I would be taking my pen, boop, my graph starts here, and I'm going to drag it to the y-axis because this is asking for range. So my lowest y value is -3. Keep going. This is not negative. This right here, this y value right here, 0, is not the highest y value. My highest y value is 4. It goes to this point and it goes through this point, so that tells me it's equal to. So if I'm not even looking at the answer choices yet. If I was writing this, it would be -3 is less than or equal to y is less than or equal to 4. This tells me that y, this graph, this y, all the y values are everything greater than -3 and less than 4, between -3 and 4. So my answer here would be B. Now I want you to notice how they're tricking you right here. They notice, okay, there's a point at -3, there's a point at 0, and there's a point at 4. So they wrote out each point trying to get you. So this would be more for a discrete graph, and this is not discrete, this is continuous. As you see, it's connected. -2 is less than or equal to x is less than or equal to 4. This is the domain. So they're trying to trick you again. And then here, you would write out your values if it was a discrete graph, which it's not. So here's a nice visual. Determine the domain. It's all your possible x values. Leftmost to the rightmost x values on the graph. And for range, it's your lowermost to the uppermost y values on the graph. So let's look at a few more graphs before we begin. So here, let's look at domain first. My leftmost part of my graph, you can pause the video if you want to try first before we talk about the answer. My leftmost part of my graph is at 1. And the rightmost part of my graph shows an arrow, meaning it's going to go forever and ever and ever. So you could say 1 is less than or equal to, or not less than or equal to because it's an open circle. 1 is less than x is less than infinity. Or we can write it as x is everything greater than 1, which it is. My graph is everything greater, all the x values greater than 1. Nothing behind 1, the graph started here. My range, this arrow is telling me it's going to go forever down, and then the highest point of my graph is 9. So I could write it as negative infinity is less than y is less than or equal to 9, or I can write it as y is everything less than or equal to 9, because the graph is everything less than or equal to 9, everything below the 9, nothing above the 9. I know it's equal to because it's going through this point. It doesn't have to have a closed circle. It's going through this point. The only time you know it's not equal to is it has an open circle. Pause the video, try this one. Domain and range. So my domain, leftmost point is -3, rightmost point is 5. This is equal to because of a closed circle. This is not equal to. So I would write it as -3 is less than or equal to x is less than 5. Range, my lowest point is 2, and my highest point is 6. So this would be 2 is less than y is less than or equal to 6. So what about if we had word problems? Here's some questions to ask yourself. Is the word problem describing something discrete or continuous? To know if it's discrete, are the values distinct? Would you only have 1, 2, 3, or a whole number of something? Or even an irrational number of something, but you have distinct values? Or could it be 1, 1.1, 1.2, 1.3? Could it be anything in between certain values? It will tell you if it's continuous. What is the independent variable? What is the dependent variable? And think about reality. That is a big thing. So let's look at this graph. The graph below represents the height of a golf ball in feet as a function of the elapsed time since it was hit. The golf ball was in the air for 4 seconds. Pause. The question here was say, what is the domain and range? The answer choices, let's start with domain. For domain, a lot of people, when I have answer choices on this one, chose X is all real numbers. But let's pause. If X was all real numbers, what is our X value talking about? What is this in the problem? It's talking about time. Well, if X was all real numbers, that means negatives as well. Would I have negative time? No. My time is starting. I hit the ball at 0 seconds. Then the ball at 4 seconds is on the ground. If I kept going, that means that the ball is under the ground. And we're not talking about it going into the hole, but that means it will be going and going forever and ever into the center of the earth. No, the domain is from 0 seconds to 4 seconds. Voice crack, excuse me. So I'll be 0 is less than or equal to X is less than or equal to 4. This is how much time the golf ball was in the air. Now let's look at the range. The range, the Y value is talking about the height of the ball. So again, would I have negative height? No. So it wouldn't be Y is everything less than or equal to 80, because that means it's everything less than or equal to 80, including negatives. No, we have to have a starting point and an ending point. So my ball starts on the ground at 0, that's the lowest point, and the highest my ball gets is 80 feet. So the range would be 0 is less than or equal to Y is less than or equal to 80. So that means this is how high, and this is how long the ball was in the air. Here's another problem. The total cost in dollars to buy uniforms for the players on the volleyball team can be found using the function C equals 34.95U plus 6.25, where U is the number of uniforms bought. If there are at least 8 players, but not more than 12 players on the volleyball team, what is the domain of the function? Okay, so this is where if you're a middle schooler, you skip some grades. So this equation might look really, really weird to you. C equals 34.95U plus 6.25. You're wondering which variable represents domain and which one would represent range. Well, this is in the format of Y equals MX plus B. If you're a 9th grader or above, this formula should look familiar to you. So C is in place of Y, meaning C represents the range. And C in this scenario is the cost of the uniforms. The total cost is represented by this equation. So the cost of the uniform is my range. U is the domain. That's my X values. X. U is being replaced with the X. And the domain is talking about the number of uniforms bought. Here's my question. Is this discrete or is this continuous? If U stands for the number of uniforms bought, would I have a discrete number of uniforms or would I have a continuous number of uniforms? Well, let's look at some examples here. If it's discrete, my answer is either H or J. If it's continuous, it's either F or G. So, if it was F, that means I have 0 uniforms and everything in between the 12 uniforms. That means I have 0 uniforms, I have 0.1 of a uniform, 0.2 of a uniform, 0.3 of a uniform, an infinite amount of uniforms between 0 and 12. Is that true? No. Either I would have 1 uniform, 2 uniforms, 3 uniforms, 4. I would have distinct values. If I had a graph, these would be distinct points on a graph, not connected with a line. Now, it says I have 8 players, but no more than 12 players. Well, am I going to order 0 uniforms? No, it says I have 8 players. So I know I'm going to have at least 8 uniforms. And I know the most I'm going to have 12 uniforms. So it's going to be everything between 8 and 12. So this would be my domain. The range would be the cost of having each of these uniforms. So I would plug 8 in for U, find out what that is, to find the cost, which would be my J answer. It's asking for domain, so the answer here is H. So this is discrete. All right. My cat is meowing at me. A scientist discovered a rock formation that grows at a rate of 0.1 meters per year. To predict the height of the rock formation after T years, she used the formula H of T equals 1.3 plus 0.01 T. What is the domain and range of the function? So it already told us H stands for height. And I showed you in the last slide, this represents y, because it's in the format of y equals mx plus b. And it makes sense. My height is my dependent variable, because it depends on the amount of time. So t represents time. That's my x. That's the independent variable. Now the question is, it's talking about the growth of a rock. Is the growth of a rock continuous or is it discrete? Well, if a rock is growing, it's continuously growing. The rock formation will be continuously growing throughout the years. So if I was to graph this, it would look something like this. I'm not going to have distinct values. Oh, only at 1 year or 2 years or 3 years, right? I can have a year, a day, 2 hours and 36 seconds, right? I can have an infinite amount of time. So it's continuous. And the height will continuously be growing. So I know that this is continuous. Let's look at some answer choices. I have T is everything greater than or equal to 0. So that means time is everything greater than 0 years. That makes sense, right? The time started at 0 years and then it goes up forever. And the height is everything greater than or equal to 0. That's a possibility. We'll talk about it. Domain is T is greater than or equal to 0. We already said that. And H of T is everything greater than 1.3. What does this 1.3 mean? What does this 1.3 mean in this equation? This means the rock formation started at 1.3 at a height of 1.3 meters. It started this way. It didn't just pop out of thin air. It wasn't 0 and all of a sudden, oh, here's a rock. No, the rock started at 1.3 meters and grew continuously at a rate of 0.01 meters per year. So this tells me the rock started at 1.3 and got bigger, greater than or equal to, consistently throughout the year. So this one doesn't make sense because that means my rock just appeared in thin air. So B is looking good. C says T is all real numbers. Well, that would include negatives and positives. I'm not going to have negative height or negative time. So this is no. And then D has the domain and range switched. So B is my answer. So try pausing it, see what you think. The total cost in dollars to buy calculator sets for the student in Mr. Ingles' math class can be found using the function C equals 75.95S plus 12.25, where S is the number of calculators purchased. If there are at least 27 students but no more than 31 students in Mr. Ingles' math class, what is the range of the function? I believe there's an error in the answer choices here, but we're going to just keep moving. Well, let's talk about something. In this equation, C equals 75.95S plus 12.25. S stands for students. That's my X value. And then C stands for the cost of the calculators, because it tells us the total cost in dollars is represented by this equation. Here's my question. If S is students, am I going to have a distinct number of students, or am I going to have a continuous amount of students? Well, it says I have at least 27 students, but no more than 31. So that means if I was doing domain, I have 27 students, 28 students, 29 students, 30 students, or 31 students. This has to be discrete. It cannot be continuous. If I say it's everything between 27 and 31, that means I have 27.1 of a student, 27.22 of a student. That doesn't make sense. So this is discrete. This is a discrete situation. So F and G are automatically out, because when I see inequalities, I know that these represent continuous situations. H is domain, and J is the range, because if I plugged in 27 for S and solved, it would give me high numbers. I don't think, the error I think is these numbers are incorrect. But, not H, my bad, J for the range. Okay. Do this problem, pause the video. Let's see if we get the same answer. So this is talking about a cross-country race. The X represents time, so we can already in our minds, we could think we're not going to have negative time. We also see there's a line here, so we know this is continuous. And then Y stands for the distance. We already know we cannot have negative time. So I know it has to be between, 0 is prominent here. So for the domain, if I was to write this out, my lowest domain value is 0, and my highest domain value is 40. So 0 is less than or equal to X is less than or equal to 40. If I was doing the range, 0 is my lowest Y value, and 7 is my highest Y value. So 0 is less than or equal to Y is less than or equal to 7. So I'm looking for an answer that matches these perfectly. Why does A or B not work? All real numbers less than or equal to blank. That means if it's everything less than 40, for example, that means also the negatives. But we're not. We have to restrict it from 0 to 40. So this is asking for domain. So A and B are automatically out. We're looking for one that matches this, so C is our answer. D is talking about the range. All right, try this one. And we already know, what's one thing we should already know? Is this, based on the graph, is it discrete or continuous? Discrete. So which answer choices could I already mark out? H and J, because they're inequalities, and it tells us it's continuous. This is asking for the domain, so it's asking for the X values. So I have X value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So F is my answer. Awesome blossom, guys. You're amazing. Have a great day.